Types of Reactions and Balancing Them by Rachel Walker. Hello. In this video, I am going to explain how to balance equations, give examples, say the type of reaction, and give examples for the different types of reactions. So first off, balancing equations. Let's say you have the given problem below. Take a look at the first element. Na stands for sodium. Notice how there is only one Na on this side, yet on this side there are 3 sodiums. We need to balance them out on both sides of the arrow. So, place a 3 by the first Na, making this amount of sodium be equal to 3, which is the same as this. Now, we want to keep this to be 3, so that it's equal to this. So place a 1 here, using the same logic that we used when we placed the 3 here. 3 times 1 equals 3, so there's 3 sodium here. 1 times 3 equals 3, so there's 3 sodium here as well. Notice, though, that each of the sodiums have a partner. They don't stand alone. In the first sodium, bromine, Br, stands next to it. Since we times sodium by 3, and bromine stands next to sodium, the bromine is also then times by 3. This creates an unbalance in the bromines, because as you see here, there is only one bromine. To balance them out, we use the same logic that we used earlier with the sodiums, and place a 3 here. However, this makes the hydrogen next to the bromine here also equal to 3. Fortunately, this isn't a problem, because as you see here, there is already a 3 by the hydrogen on the first side of the arrow. Now, we want to keep the hydrogens to be equal now. As you see, they're already both balanced, and we want them to remain that way. So place a 1 here. This makes it so that the phosphate here, next to the hydrogen, will have to remain 4. And that isn't a problem either, because there's already 4 on the second side of the arrow, times 1, means there's 4 phosphate here, and 4 phosphate here. So there you go. The equation is balanced. Now, types of reactions. There are 5 types of chemical reactions: combustion, synthesis, decomposition, single displacement, and lastly, double displacement. A combustion reaction is when the oxygen combines with a compound to form water and carbon dioxide, like in the equation here. Here's the compound, here's the oxygen. Both of them combined together results in carbon dioxide and water formed. Synthesis. A synthesis reaction is when 2 single compounds combine to make a more complicated compound, as in here. There's iron alone, combined with sulfur alone, creates iron 2 sulfide. Decomposition. A decomposition reaction is a complex molecule broken down into 2 simpler ones. For example, see the initial complex molecule. It's then broken down into the 2 simpler molecules which make it up. Single displacement. A single displacement reaction is when one element moves to create another molecule, as in below. You see how oxygen is the only element which changes its place. Everything else remains still. Double displacement. A double displacement reaction is when the anions and the cations of 2 different molecules switch places and form 2 new different compounds. As in the example, here, the H and the I switch places in the end result. So now that we know all the different types, let's look back at our previous equation. See how the Br, bromine, and the PO4, phosphate switch places, this means that our reaction is a double displacement reaction. Thank you for watching and listening. Hope you have learned a lot and enjoyed this. Bye!